Okay. So couple equal concept হচ্ছে if we have two equal parallel opposite forces which are offset from each other. Offset from each other means they are not working in the same line of action. Together that pair is called a couple. The moment of a couple is given by one of the forces multiplied by the perpendicular distance between them. Where do these two forces work? Really doesn't matter, because we can actually calculate the moment of a couple considering any point on the object as our pivot point. So, or outside the object for that matters. For example, if you have a look at this figure, let me take that out. So if you have a look over here, in this case, we are calculating the couple of these two forces considering different points as our pivot point. So what I want you to see over here, we have an object, rectangular bar, let's say, which is AB. On this object, the two forces are working at, one is at A point working downwards, and another is working at B point working upwards. They're equal, parallel, and they're working at a far distance from each other. They're opposite in direction, so they're producing a couple. If we consider the moment of this total couple with respect to point A, so if for this question we're considering the pivot point, hypothetical pivot point to be A. If we calculate the moment about A point, the moment of this force about A point is 0, because it is going through that point. Whereas from this point all the way up over here, the perpendicular distance over here is totally D, because that was labeled over here. This is the total distance is D. So the moment would be only produced by this force, which is equals to F into D. That's just one simple way to go for it, considering one of the force acting point as our pivot point. But if we don't want to do that, if we want to calculate the couple torque produced by the couple, let's say by considering the middle point, let's say if we consider this point exactly at the middle, this point as our pivot point. So for pivot at the center of the rod, in that case, this much is D by 2, and we are producing an anti-clockwise moment like that. This much is D by 2 producing an anti-clockwise moment like that. So we add both these two. So F into D by 2 plus F into D by 2, together you still get FD. Same thing as earlier. Then again, if you don't want to consider the exactly midpoint as our pivot point, if you want to choose any random point in between the two forces as our pivot point, let's say if I want to consider this random point as my pivot point, in that case I'm using red over here. So if I consider this point for my pivot point, let's say the distance of the left force over here is X, and the distance over the right here over the distance is D minus X. So the total couple produced would be anti-clockwise moment of F into X, which is this much. So for pivot at any random point, F into X plus F into D minus X. So together, if you do the mathematical sum of this, you are still going to end up with FD. So that's that point. The last scenario, that if you want to consider a point that is outside the object, that is also okay. If you want to measure the moment for a location that is right over here, so let's say this object, this hypothetical pivot point is outside the object on the left, then we can also consider that in that case this is going to produce a clockwise couple. For a pivot point consideration over here, this is going to produce an anti-clockwise couple. The distance of this force is Y. Distance of this force is Y plus D. So for pivot point outside the rod, in this case, I considered anti-clockwise moment as positive. No, sorry, I didn't consider that. So disregard that. So the total couple produced or torque of moment produced by this force should be Fy minus F into Y plus D. So I wrote the last one later. The reason I gave a minus n over here because they are opposite directional moment, and ultimately I got minus Fd. In this case, minus Fd is actually meaning that the total couple would be in the anti-clockwise direction, because essentially you can see that this moment the moment produced by F into D plus Y, this total thing should be bigger compared to the moment produced by F into Y right over here. So altogether the stronger moment would be produced by this force. So you're going to have an anti-clockwise moment, which is going to be Fd as well. I have the minus n over here because I wrote this part first. If I wrote this part first, I'll get positive number. Not a big deal. Point that I'm trying to show you over here, that no matter which point I consider for our pivot point, we're going to end up with the same expression, that the torque or moment produced by a couple is actually Fd, not 2Fd. So one of the forces multiplied by the perpendicular distance between them gives us the magnitude of the torque produced by a couple. So that's an important factor. And one other important bit for you to understand and remember is that for any object where these two forces work is does not at all define their couple. For example, we have one of the MCQs. Let me just pull that up. Which is this one. Let's have a look at question number 18. Have a look at question number 18, this one. Which of the following pair of forces acting on a circular object constitutes a couple? Now you need to understand, for two forces to produce a couple, they have to be of equal magnitude, they have to be parallel, they have to be offset from each other, not working in the same alignment, and they have to work in opposite direction. So these logics are exclusively fulfilled for option choice A, not for B, not for C, and definitely not for D. Now, some students find it difficult to choose option choice A because they see that, well, one of the forces working at the center, the other is working on the side, so they are not going to produce a couple. The answer is they will definitely produce a couple. Couple applicable to the a pair of forces to be considered as couple. It doesn't matter where they work. It all matters that whether we are fulfilling those four required conditions. We have to have equal forces, parallel forces, working not in the same alignment, and opposite forces. If these four conditions are fulfilled, that pair of a force can be considered as a couple. So working location really doesn't matter. Here, one of the force working at the center, the other force is working on the side, but this one is the correct response for this question. None of these other questions are acceptable. Now you might wonder, what if we had a scenario that looked like this? Let's say if we had a scenario within this question where we had one option look like this, one F over here, one F over here, and also we had A in A given as well as the correct answer as well. So what about then? So if we had this option and all of these options as well, well, the question would never have that. MCQ questions will never have correct answer, multiple correct answers within your answer keys. So that's not going to happen. Point that I'm trying to highlight over here, that the position of working for the forces really doesn't matter. All that it matters is that whether we have those conditions fulfilled or not.
স্যার
হ্যাঁ বলো।
স্যার কাপল সেশন হচ্ছে দুইটা ফোর্স হতে হবে, দুইয়ের বেশি তো হতে পারবে না।
না না না, there has to be two forces equal, parallel, opposite, away from each other. So এটা হচ্ছে coupleর basic discussion, that how do we define a couple and so on and so forth. Couple calculation গুলো আমাদের জন্য মোটামুটি ইজি আছে, but we're gonna see more about that. আচ্ছা, এরপর যে জিনিসটা আমাদের আছে সেটা হচ্ছে যে আচ্ছা এরপরের পার্টটা আমি একটু এঁকে দেখাই। Whenever a certain object is considered to be in equilibrium, hear me out, whenever a certain object is considered to be in equilibrium, we have two conditions. We can imply two conditions on that situation. For equilibrium with or of an object, first condition, resultant force should be zero, and second condition, resultant moment should be zero. এই ফোর্স জিরো হওয়ার একটা ইমপ্লিকেশন আমরা আগের ক্লাসে দেখছি। ফোর্স রেজাল্টেন্ট ফোর্স জিরো হওয়ার একটা ইমপ্লিকেশন হচ্ছে the vector diagram of all of those forces drawn with appropriate angle and appropriate scale should give us a closed polygon. That's a very simple way to put it. The implication of the resultant moment working on an object to be zero can be considered in a different way. That way is, if multiple forces working on a single object produces zero moment, then all of those forces would be concurrent. Concurrent means if we extend the line of action of all the forces, they would all pass through a single point. I'll say it again. If we extend the working line, or if we extend the alignment of all the forces, all of those forces would perfectly go through one single point. And this, if this logic is fulfilled, we can say the moment of all those forces about that point is zero. And that would also imply that moment of all this force about any other point is also zero, because you cannot have different amount of moment produced by some given amount of forces. One simple example that was given in the worksheet that looks like this. Let's say we have a wall and we have a hinge over here, and with that hinge we have attached a plank. Let's say this plank is supported by a piece of string that is right here, and the plank has some weight. So this string is producing a tension force over in this direction. The weight is working vertically downwards. We are considering uniform rod, so or uniform plank. So that's why the weight is drawn about from the middle of the object working downwards. Now the question is, will these two forces by their own self can produce an equilibrium? Can these two forces produce an equilibrium or not? The answer is a solid no, because you can see it very well that this is a vertically downward force. If we consider that theta over here, uh, a downward force cannot actually perfectly ever uh, um, encounter or perfectly rebalance an oblique force. So these two forces will not produce an equilibrium. So the other third force that we have always available in a situation like this, which comes from the hinge point. This hinge also applies a reaction force on this plank on the left corner in such a way so that the resultant of all of those forces, the tension of the string, the weight of the plank, and the reaction force coming off the hinge, together these forces actually become zero. It gives us a zero resultant. And how can we find out the direction of this force? I'm not saying about magnitude. Magnitude can be calculated by a set of formula. I'm going to show you the formula as well, no big deal. But to find out the alignment, possible alignment of this force, what we can do, we can simply find out the possible cross point of these two forces that we have available. For example, the W and T, they are going to cross on this point, which means the reaction force that we're going to have at this location of the plank is going to work exactly that, so that the force of alignment should go through that point as well. So this is how the reaction force should look like. Now you might wonder, sir, you might wonder that why did I prefer to draw it upward or not on the downward side? I mean, why didn't I draw it in this way? I mean, that could also give us a working line like that. The reason is very simple. The reason I didn't draw it in this way is by very simple understanding of how the balancing was going to work. If you consider that the R force doesn't exist altogether, let's say if this reaction force did not exist, you can see that weight is working downwards and T is working upward left, which means within the T, if I go for the component division, Ty is going to work vertically upwards and Tx is going to work vertically to the left. এটা তো বুঝতেছো?
Yes, sir.
ঠিক আছে, তার মানে আমার এই Ty এর একটা পোরশনকে ব্যালেন্স করার জন্য W enough. These two forces can balance each other given a given enough number. But if we want to balance a Tx component, which is working to the left, the third force must have a towards right component, not a towards left component. That's really important. So আমার এই পয়েন্ট থেকে আমি যে রিঅ্যাকশন ফোর্সটাকে আঁকতেছি, the reaction force that I'm drawing from this point, working from the hinge, the direction of the hinge, that reaction force should be responsible to compensate for the resultant. So that way it must have a component of its own so that it can balance this leftward force. That would essentially imply that the reaction force should have a component towards right so that these two components can balance each other out. That's why drawing it to the downward left direction is not the correct choice. Rather, drawing it on the upward right direction is the essential correct choice. If we try to so the bottom line of this discussion is that if we have multiple forces working on an object where the object is defined to be in equilibrium, or if we want to derive the condition for the equilibrium, for resultant moment to be zero, all the forces must go through the same point. Now the forces might need their working line to be extended a little bit, and this point that we have over here might in many cases fall outside the object. For example, you can have an object right over here, let's say it's like this, whereas multiple forces work in this direction or maybe in this direction. So you can have that crossing point of multiple forces outside the object. It doesn't have to be exactly on the object. For example, in this case, we are trying to find the equilibrium condition for the plank. We are trying to find out the equilibrium condition for the plank, and the cross point for all the forces falling on the string right over here. It is not within the plank. That can also very happen. So that's how we define the direction of the reaction force. Now, if we want to find out the conditions for equilibrium, how can we go for it in a much detailed way? Let's say this angle over here is theta. Let's say the R produces an angle of alpha over here. For my drawing, they are appearing to be equal angle, but trust me on this one, they are usually not equal because they are not likely to be equal in the first place. And then we can simply go ahead to find out the resultant force equation out of these forces pretty simply. If I try to write the equation for the horizontal axis, so I have a good look over here. So if I go for write the horizontal axis, I can write r cos alpha should be equals to, actually other than writing should be equals to, I can write by the sense of equilibrium, r cos alpha minus t cos theta should be 0. I mean, the sum of all the horizontal forces constantly towards right is positive. And for the vertical axis, sum of upward forces should be equal to sum of downward forces. So considering upward forces as positive forces, I can write r sine alpha plus t sine theta minus w should be also 0. So r sine alpha হচ্ছে এদিকে, t sin theta হচ্ছে এদিকে. So the sum of these two vertical upward force minus the vertical downward force, that should also give us 0. This is the force equation that we have, and provided we have all the variables available in any applicable cases, we can solve of these two equations to find out any of the unknown that the question asks us to find out. এই বিল্ড আপটা বুঝা গেছে কিনা so far?
আর কি রেজাল্টেন্ট ফোর্স নাকি প্ল্যাঙ্কের দেওয়া ফোর্স?
Reaction force on the plank from the hinge.
Yes, বুঝছি।
ঠিক আছে
স্যার cos আর sin এটা আমরা কিভাবে বুঝবো স্যার?
The cosine component is the adjacent component. So if theta is over here, the cosine component would be in the touching side of the theta angle along with the hypotenuse, and sine component is the vertical component.
স্যার আরেকবার বুঝতে পারবেন রেজাল্টেন্ট মোমেন্টে সবগুলো ফোর্স সেম পয়েন্টে যাবে, এটা লাইনটা আরেকবার মেনশন করতে হবে।
Yes sir.
Initially we had the green figure, ঠিক আছে?
Yes.
And then I wanted to find out in which direction the reaction force from the hinge should work. To find that out, I first extended the W force backwards to find out this point where the force T and W cross on each other. If these two forces cross on this point, which means the third force which should be available from the hinge should also go through this point. And third force's starting point হবে হচ্ছে hinge. একটা আরেকটা পয়েন্ট হবে এরকম। তার মানে থার্ড ফোর্সটা আমার এদিকে হইতে পারে, এই এলিমেন্টে হইতে হবে, এটা হচ্ছে কথা। মানে this should be the element of the third force or the reaction force coming off the hinge. This should be the element of that force. Now this force might be considered to be upward right, or this force could be also considered to be downward left. And downward left কেন হবে না সেটা আমি এক্সপ্লেইন করছিলাম tx দিয়ে। যেহেতু আমাদের t এর অলরেডি একটা টুয়ার্ডস লেফট কম্পোনেন্ট আছে, ওটাকে ব্যালেন্স করতে হলে অবভিয়াসলি আমাদের থার্ড ফোর্সের একটা টুয়ার্ডস রাইট কম্পোনেন্ট লাগবে। কারণ টুয়ার্ডস লেফট কম্পোনেন্টকে তো আমি টুয়ার্ডস আরেকটা লেফট কম্পোনেন্ট দিয়ে ব্যালেন্স করতে পারবো না। They should work against each other, right? ওই জন্য আমি আর রিঅ্যাকশন ফোর্সটাকে আপওয়ার্ড রাইট ডিরেকশনে আঁকছি, and ultimately if we go for the equation, this is how the equation set might look like. বুঝা গেছে?
স্যার
হ্যাঁ বলো।
স্যার যদি যে টেনশন ফোর্সটা, স্যার এটা যদি আমি রোপটা যদি আমি আরেকটা ওয়াল থেকে টাঙায় রাখতাম লাইক রাইট সাইড থেকে, তখন কি রিঅ্যাকশন ফোর্সটা ডাউনওয়ার্ড লেফটে কাজ করতো?
হ্যাঁ, beautiful question. So I can draw this up for you. Let's say we have one wall over here. Let me try and draw this. So we have one wall over here where we have a hinge, and this is the hinge, and we have a plank set on that hinge. So the plank is over here, and let's say we have another wall over here a bit far away. So this is a wall. This is another wall. Let's say we have another support point like this. এটা তো তোমার কোশ্চেন, রাইট?
Yes sir.
নো প্রবলেম। সেই কেসে যেটা হইতো যে ইজ দ্য সেম প্রসিডিউর। মনে করো এইটুকু আমাদের দেওয়া আছে, সো উই ডু আন্ডারস্ট্যান্ড দ্য ওয়েট ইজ গোনা ওয়ার্ক ভার্টিক্যালি ডাউনওয়ার্ডস লাইক দ্যাট, and the tension in this case is going to work upward right because the wire should pull on the object to keep it horizontal. So simple, we're simply going to extend the two forces so that we can find out their possible cross point. Now you can see আমি যদি এই ফোর্স w টাকে উপর দিকে উঠাই, কখনোই আমি এই ফোর্স দুটার ক্রসিং পয়েন্ট পাবো না। পাবো
না স্যার।
So essentially আমাদের ক্রস পয়েন্ট পেতে কি করতে হবে? আমাকে নিচের দিকে এক্সটেন্ড করতে হবে। So that's a very simple idea of drawing. So if you cross the point downwards over here, this is the crossing point of the W and T force, which means in this case the reaction force should work along this alignment. And once again, because T gives us a towards right component, because T in this case, let's say this is our theta over here, T has by default a towards right component, so the reaction force should work upward left. That's just by judgment. So let's say if the reaction force over here works as alpha, now you have the same set of equation can work for this case because I chose the variables placed appropriately. মানে রিঅ্যাকশন ফোর্সের অ্যালাইনমেন্টটাকে আমি রাইট দিকে দিব নাকি লেফট দিকে দিব, সেটার জাজমেন্ট আসলে হচ্ছে টি এর হরিজন্টাল কম্পোনেন্টটা কোন দিকে সেটার উপর বেস করে। এই পার্টটা বুঝছো কিনা দেখো।
ইয়েস স্যার বুঝছি।
ঠিক আছে?
Yes, sir.
আর অ্যাকচুয়াল অ্যালাইনমেন্টটা কোন দিকে হবে সেটা বাই করতে হবে হচ্ছে ডাব্লিউ আর টি এর ক্রস পয়েন্ট থেকে আর হিঞ্জ পর্যন্ত একটা লাইন আঁকলে যে লাইনটা হয় রিঅ্যাকশন ফোর্সটা ওই অ্যালাইনমেন্ট বরাবর হবে। এখন সেই অ্যালাইনমেন্ট বরাবর কি আপওয়ার্ড লেফট নাকি ডাউনওয়ার্ড লেফট নাকি আপওয়ার্ড ডাউন, রাইটওয়ার্ড আপ অর ডাউনওয়ার্ড রাইট, ওইটা হচ্ছে জাজমেন্ট করতে হবে হচ্ছে টি এর হরাইজন্টাল কম্পোনেন্ট থেকে। এই হচ্ছে দুইটা জাজমেন্টের উপর বেস করে আমরা রিঅ্যাকশন ফোর্সটা ডিরেকশনটা আঁকি।
তাহলে স্যার ইকুয়েশনটা কি স্যার চেঞ্জ হয়ে যাবে?
কোন ইকুয়েশন?
মানে x কম্পোনেন্ট এন্ড y কম্পোনেন্ট?
না না না, এখানে ইকুয়েশন চেঞ্জ হবে না তো। আমি এখানে মনে করো হচ্ছে এখানে লিখছিলাম যে আর cos আলফা মাইনাস টি cos থিটা, কারণ টি ছিল এখানে বাম দিকে। এখানে আমি সিম্পলি লিখবো হচ্ছে মাইনাস আর cos আলফা, বিকজ আর cos আলফা ইজ ওয়ার্কিং টুয়ার্ডস রাইট, cos alpha plus t cos theta equals to 0. Basically the same equation. And as for the components over here, I'm gonna write upward components equals to downward components. So I can write r sine alpha, which is the vertical component of r, plus vertical upward component of t sine theta minus w equals to 0. You're basically gonna have the same set of equation. Just horizontal forces দুইটা reverse হয়ে গেছে।
ওকে স্যার।
বলুন বুঝা গেছে কিনা?
ইয়েস স্যার।
আচ্ছা, এটার উপর বেস করে আমি তোমাদেরকে খুব সিম্পল একটা এমসিকিউ দেখাই। হ্যাঁ হ্যাঁ, কোথায় গেল? একটা স্পেসিফিক এমসিকিউ মাথায় আসছিল, এই যে 47। দেখো question number 47, which one do you think is the correct response? You can use your ruler on the screen that you have, or you can use your ruler on the worksheet as well. This is on page number 9 of the MCQ paper for the first one, but you can use it on your ruler on the screen. Which one do you think, for which option the body cannot be in equilibrium? কোনো ভ্যালু দেওয়া নাই, শুধু অ্যালাইনমেন্ট দেওয়া আছে। What do you think is the correct response? I'll give you a small hint. Try to draw up all the forces so that to find out their possible common cross point. For only one option choice, you'll see that one single cross point is not available. And that is the case where equilibrium is not possible.
Then sir, how is there a cross point in number B?
Extend the forces in the inside. Just draw dotted lines on the inside of that hot air balloon. This is not a hot air balloon. It's this objects have a name. I'm ভুলে গেছি। এগুলো জানি কি বলে?
Submarine sir.
ব্লিপ।
Is it a submarine? Submarine তো উপরে পেরিস্কোপ থাকার কথা না, এগুলো সাবমেরিন না, এগুলোর একটা নাম আছে।
সেগুলো ব্লিম্পস বলে না, BLIMP।
ওই যে যেগুলো অনেক বড়
Sir,
একটা
ships like
অ্যাক্সিডেন্ট হয়েছিল যে, হ্যাঁ
এয়ারশিপস।
I think airship, yeah, Kirov airship.
স্যার ব্লিম্পস তো বলে BLIMP।
আচ্ছা দেখতেছি, ব্লিম্প দেখতেছি, yeah, these stuffs. আরটা কি বলছো blimp?
Yes, sir.
Ah, yes, they are also called blimps. Yes, beautiful. I did not know this word. Yeah, that's the figure for a blimp. So the point there is that you just try to extend these forces backwards and find out for which case you do not have a single point of contact. I can see for this option they already have a single point of contact, which means the resultant moment can be 0. If I extend these three forces backwards, you will find out that they also have a perfect single cross point. If you extend these forces backwards, you will find out these things also have a perfect single cross point. But for this one exclusively, you will not have a perfect single cross point. If you extend this one backwards and this one backwards, you're going to have a force over here, and this one is going to go through here. So they are not actually having a single cross point. So here the resultant moment cannot be 0, which means this thing cannot be in equilibrium. It's a very simple process, but provided you know how to approach this problem, depends upon how easy or difficult it can be. বুঝা গেছে?
Yes, sir.
আচ্ছা, এরপর আমাদের যে সিচুয়েশনটা আছে on the class notes, if we go by, is the condition for minimum force required for toppling or rolling over. আচ্ছা, এটা আমি এখান থেকে কপি করে নিয়ে দেখাই। Have a look at this one. Conditions for minimum force required for toppling or rolling over. So toppling or rolling over means that we want to tilt over this object on the right side. What is the minimum force required for this process? Now you might wonder why the term minimum force is required. I mean, why not it can be only force? I'll explain this. Try to have a look. This is a rectangular object which is now staying on this surface. There is enough friction that whenever we're going to apply force on the from the left side, this object is not going to slide, it's rather gonna flip over. So first thing first, whenever we're going to push onto this side, this force is going to produce a clockwise moment about the pivot of this point. This is going to be the pivot point for the rolling action. So what I need to observe or visualize, whenever this rectangular object is going to roll to the right, it's going to use this corner as the point of rotation. So this side is going to this side is going to start to become tilted, and this side is going to slowly start to lift off from the ground, and the object is going to go through a tilt action, and eventually that the object is going to fall, something like that. Oh, that's a beautiful rectangle. Oh, nice. So that's how the object is going to fall. My figure is not drawn to scale, it became a bit bigger, but I think it's understandable. So এই জিনিসটা হবে. Now what is important, that whenever this point will be considered as the equilibrium point, as the pivot point, we're going to have to work against the moment produced by the weight. So if you consider this an uniform object, uniform rectangular object, the center of gravity is right over here, weight is working from this point vertically downwards. So we have an anti-clockwise moment about this point. From this point of working, we have an anti-clockwise moment like that, which is W into B by 2. I'm using B by 2 because I'm considering the base length to be B, and this much should be half of that, so that is B by 2. So W into B by 2 gives you the anti-clockwise moment of this much. This is a by default moment that will be built up within the object. To make the object topple over, by applying a horizontal force, we must produce a moment that is at least equal to this moment. If you wonder that why am I using the word at least, because if I use a moment bigger than WB by 2, I'm definitely going to topple it over. To have the object toppled over, applying a moment exactly equal to this one would not start the rotation. But if we apply a little bit bigger force than minimum force, the rotation can be started, and then we can maintain that force. So we are trying to discuss the situation for the limiting factor, or what would be the minimum force required for the F to be applied. Now you should understand, whenever we're going to apply this force is going to work in this alignment, and but this is the pivot point. So this length, let me draw it red. This length is going to work as a perpendicular distance for the force F. Because this is going to work as our perpendicular distance, so we will definitely require the minimum force whenever we will apply the force on the highest level of the object. মানে হচ্ছে আমি যদি ফোর্সটাকে এখানে অ্যাপ্লাই করতাম তাহলে আরো বড় ফোর্স লাগতো, যদি এখানে অ্যাপ্লাই করতাম আরো বড় ফোর্স লাগতো, কারণ হচ্ছে for all the lower forces the H would be much smaller. So to equate the moment available from the weight into B by 2, we'd require a bigger force. So we should preferably apply the external force, the toppling force, in a position so that the perpendicular distance of that force from the pivot point is the maximum. That's why this force should be applied on the very top surface. In this case, h is the height of the object. So for the minimum force to topple over, ACM equals to WB by 2, ACM equals to CM, so W into B by 2 equals to FH. That basically defines our requirement force. Now এই প্যারাগ্রাফটা আমরা একটু পড়ে দেখি, এরপর ফার্দার কিছু জিনিসপত্র আমি আলাপ করি। এই প্যারাগ্রাফটা অনেক ইম্পর্টেন্ট, বুঝে পড়া ইম্পর্টেন্ট, খেয়াল করো। If this cuboid rolls over, either x or y will be the pivot point. I'm writing x or y because it could be also toppled over by applying a force from the right where the object might topple over in this direction. এটাও পসিবল ছিল, বাট ওটা আমরা এখানে আলাপ করি নাই। That's why x or y both are considered to be pivot point. The ACM produced by W about y is W into B by 2. To roll it over to the right side, we have to match this moment in clockwise direction. To have this done with least force applied force must be furthest away vertically from y and horizontal, in which case CM or clockwise moment is FH. For minimum force cases, we deal with terminal or critical equilibrium. This means ACM equals to CM. To start the rolling process, initially we'll need a slightly bigger clockwise moment than anti-clockwise moment, but for the duration of rolling, ACM equals to CM is enough. মানে হচ্ছে আমাদের রোটেশনটা স্টার্ট করার জন্য for a fraction of second we have to apply a slightly bigger moment so that the rotation can start, but for the duration of the rolling we can simply keep on applying that exact amount of force and this is going to work just fine. এখানে একটা জিনিস খুব important, or I can say interesting, is that for the entire duration of rolling we should keep applying this same amount of force even as long as the object does not start to roll down on its own. এই জিনিসটা আমি একটু এখানে বুঝাই। এটা অ্যাকচুয়ালি এখানে তো আমি একটা অবজেক্টকে সহজে ঘুরাইতে পারবো না, ঘুরাইতে পারবো? Let's see if I try to draw a line. Can I rotate this? I can. Actually. Okay, beautiful. Let me show you another part of observation for the case of rolling or toppling cases. এই পার্টটা একটু ভালো করে খেয়াল করো। Become a rectangle, come on. Good. আচ্ছা বললাম, I cannot honestly actually make this figure rotate by the center, so I'm actually using I have to continuously rotate and shift. So মনে করো, let's say we're applying a force in the horizontal direction starting from this point, so we're applying a force F over here and thus object is starting to roll over. So for the rolling action to work, we have to keep on applying this force till the object doesn't topple over. And at which point the object will topple over? The object is going to topple over till the orientation the object is pushed to this level, to about, not quite, to about this level, right?
Meaning, sir, when the center of gravity is right on the pivot.
Exactly. We have to simply push the object past the pivot points for the object to topple over. So এখন ঠিক আছে। So এটা যখন আমরা অ্যাচিভ করতে পারবো, so up to this much point আমাদেরকে ফোর্সটা পুশ করতে হবে and then the object is going to start topple over. Now an important consideration is that for this entire movement, as the pushing force position over here, on a pushing force এর পয়েন্টটা এই আর্কে মুভ করার throughout the duration, আমাদেরকে F4C অ্যাপ্লাই করতে থাকতে হবে। So you have to keep on applying the same force. There is a certain reduction factor in play here, which I want to discuss with you. সেটা হচ্ছে, let's say initially the weight was working from this point. So what is working over here? This is B/2. এখন মনে করো, and H was over here, and the moment clockwise moment we are producing is FH. So at the very beginning case, FH is equals to W into B/2. এখন whenever we'll start the rotating, before the toppling actually happens, just halfway in the process of rotating, let's say the object is at this position. Let's say, how would the moment change? What would be the actual moment of the situation in this scenario? Because you should see over here that by applying the F over here, the application point of H is becoming bigger. So let me just draw this forces once again. I'm going to use blue. Let's say when the object is tilted to this much level, you should see that F should be working in the existing position, and now the applied force has a pivot perpendicular distance with the pivot, which is this increased height, ঠিক না? Up to this much, ঠিক না? ইনিশিয়াল পয়েন্ট আমাদের হাইট ছিল এইটু, বাট যখন আমাদের অবজেক্ট রোল করা শুরু করবে, আমাদের এই কর্নারটা তো আস্তে আস্তে উপরে উঠে যাবে। As this corner starts to go higher, which means the perpendicular distance for the force F is going to become bigger. Should it not?
Yes, sir.
ঠিক আছে? Which means for the clockwise moment, which is FH, because H is going higher, which means the clockwise moment will naturally start to go higher if we keep the F constant. However, what happens to the anti-clockwise moment, which we are trying to balance? What is happening to the anti-clockwise moment that we are trying to balance? As the object starts to roll over, you should understand, let me draw this with blue once again. This center of gravity of the object will also rotate about this. For example, a case here, whenever the object is in the tilted condition, let's say the center of gravity is right over here. I'm trying to approximately get the diagonal cross point. So what is happening, as this application of force point is going through this arc, this center of gravity is also going to travel in this arc. If you wonder where these arcs are coming, they're all actually having the center right over here. So I can say actually that this hypothetical diagonal, and this hypothetical diagonal, this diagonal is working as the radius. Okay, this diagonal is making the rotation. So the center of gravity of this object is moving to the same position of the center of gravity. And you should see, as the center of gravity moves by, the weight is working in the same position. But what is happening to the perpendicular distance of the weight from the pivot point? মানে হচ্ছে এই যে নতুন ডিসটেন্সটুকু, মানে হচ্ছে এই যে এটা হচ্ছে ওয়েট ওয়ার্কিং পয়েন্ট, এখান থেকে আমাদের এই পয়েন্টের ডিসটেন্সটা আগের থেকে কমে যাচ্ছে না? At the initial position, the perpendicular distance was B/2, but as the object keeps on rolling, the perpendicular distance of weight from the pivot point is slowly becoming closer, because this weight arrow is slowly pushing to the right. ঠিক কিনা? বুঝতেছো? হ্যালো,
Yes, sir. শোনা যাচ্ছে।
বুঝছো কিনা?
Yes, sir.
ঠিক আছে? So as the object keeps on rotating, the weight arrow is going to be slowly moved to the right, which means the perpendicular distance of the weight force from the pivot point, which was initially B/2, that distance is slowly going to become smaller, which means as the object keeps on rolling, the anti-clockwise moment produced by W into B/2, while W is the definite constant, this is actually slowly becoming smaller. It obvious মানে হচ্ছে, for the rotation process, the clockwise moment requirement at the very beginning would be the highest. I mean, F has to be the highest force at the very beginning, because that's when you had the biggest anti-clockwise moment by W into B/2, which should be separated by the smallest of the h values for the whole motion at the beginning, which means the f requirement would be the highest at the very beginning. As the object keeps on rolling, আস্তে আস্তে আমাদের anti-clockwise moment কমে যাবে. So as the anti-clockwise moment decreases, the requirement for clockwise moment will also decrease, which and also so the requirement of clockwise moment decreases. At the same time, because of the increase of this h perpendicular distance, the actual value required to maintain that lower clockwise moment, the value of f would also be reduced, which means we have to support a smaller clockwise moment as the rotation keeps on happening. As the rotation keeps on happening, we have to support a smaller anti-clockwise moment where the perpendicular distance that we have available for the application of force F, that one is becoming bigger. Both of these factors will attribute towards a smaller requirement of the applied force F. তার মানে হচ্ছে আমাদের F force এর required ভ্যালুটা আস্তে আস্তে কি হবে, কমে যেতে থাকবে। এই পার্টটা কি বুঝতেছো? Which means we are going to need the maximum amount of force to start the rotation. As the rotation continues slowly, the requirement of that force value is slowly going to become less and less. This is why we use this term over here. The reason I'm telling you all of this part is to highlight the word minimum, that this is the minimum amount of force that is required to start the rotation. As the rotation continues, we can choose to apply less force because the process will, by its own virtue, will require less force. Because we have to, as the rotation continues, slowly the anti-clockwise moment produced by the weight is going to become less, and also the perpendicular distance available for the F force to work will become more. So the same rotation can be maintained with a much smaller amount of force. So we don't have to apply the same F continuously to the process. I think I said that a bit earlier. I stand corrected. I retract my words. The application of force F, we don't have to apply the same force over to maintain the rotation. Just to overcome the anti-clockwise moment, this F requirement is going to become significantly smaller. তার মানে যত আমরা পুশ করতে থাকবো আমাদের পুশিং এর এফোর্টটা তত কম দিতে হবে. The further it get closer to the vertical point, this F force requirement would become very smaller and smaller. Eventually, right at the verge of toppling over, I mean when this corner is going to be perfectly above the initial vertical edge, the F requirement is going to become 0, because beyond this point we don't have to push anymore. The object's weight itself is going to make the remaining of the rotation to make the object fall down. বুঝা গেছে কি পোলাবান?
Sir, will the rotation of the rotation matter over here, sir?
Yeah, rotation is matter. The rotation does matter because it is because of the rotation, this perpendicular distance, anti-clockwise moment perpendicular distance, this was becoming less, and this is, and the h of the fh, this is becoming more because of the rotation, which means that slowly the anti-clockwise moment that we have to overcome, that becomes lowered, and the perpendicular height that through which we can apply the force F, that is becoming more, which means the F would become smaller. That's the key point.
I mean, sir, will it be important when it comes to MC questions?
No. This is a concept that you need to understand.
Gotcha.
Why did we use the term minimum force at the beginning? The reason we use the term minimum force, because in this whole process for the object to be toppled over, we have to keep applying this force F from this point all the way when the object actually becomes perfectly vertical. For example, when the object becomes right at this orientation. So when this is perfectly above this point, so this is the point. Beyond this point, the object is going to fall down. Not perfect drawing, but you do understand. I mean, when the COG becomes perfectly above the pivot point, এই point পর্যন্ত আমাদের ফোর্সটা অ্যাপ্লাই করতে হবে, and এই throughout the motion from the starting all the way to the tipping point, আমাদের এই F force এর ভ্যারিয়েশনটা কেমন হবে সেটা নিয়ে আমি আলাপ করতেছি. Initially, the required force would be the biggest. As the rotation continues, the F force required to maintain the rotation would slowly become smaller and smaller. Make sense?
I think so, sir.
Sir, force-টা কমবে কেন?
কারণ কম anti-clockwise moment support করতে হবে through a bigger vertical height.
জি স্যার। স্যার ওইটা কি বলা যায় ডিউ টু মোশন এয়ার রেজিস্ট্যান্সের কারণে একটু কমতে পারে?
No, we are dealing with not so fast objects that air resistance should be any important factor for this question. The object is not moving so much to experience air resistance whatsoever. Air resistance is not a factor over here, not at all.
The ফোর্সটা কমবে টু ফর দ্য অ্যান্টি ক্লকওয়াইজ ওয়ান। স্যার
হ্যাঁ বলো।
স্যার the original force-টা কমবে to match to be equal to the clockwise the clockwise moment will sorry sir ভুল বলতেছি। হ্যাঁ the clockwise moment, the force producing the clockwise moment will increase to be equal to the anti-clockwise moment produced by the weight, ওটার জন্য ডিক্রিজ করবে।
না, you are approaching the problem in a bit wrong way. I'll say what is happening. জিনিসটা সিকোয়েন্সটা বুঝো। আমাদের এইম হচ্ছে এই অবজেক্টটাকে টপল করা। অবজেক্টটা টপল করার জন্য আমাদের একটা ক্লকওয়াইজ মুভমেন্ট প্রডিউস করতে হবে বাই অ্যাপ্লাইং দিস এফ ফোর্স হুইচ শুড at least balance the anti-clockwise moment. এইটুকু হচ্ছে সিনারিও, তাই তো? Anti-clockwise moment is produced by the weight. To make the toppling over, we have to match the anti-clockwise moment at any point of the rotation. Now the point is that so object যত রোটেট করতে থাকবে আমাদের anti-clockwise momentটা তত কমবে। এটা বুঝছো কিনা? কারণ এই ওয়ার্কিং পয়েন্ট আস্তে আস্তে আমাদের পিভট পয়েন্টে ভার্টিক্যালি কাছে চলে আসতেছে। সো যেহেতু অ্যান্টি ক্লকওয়াইজ মোমেন্টটা কমে যাচ্ছে, তার মানে আমাদের ক্লকওয়াইজ মোমেন্টও কম প্রডিউস করতে হবে, রাইট?
জি স্যার।
এন্ড ক্লকওয়াইজ মোমেন্ট কম প্রডিউস করতে হবে, তার মানে কি আমাদের এফটা কম লাগবে। এটা হচ্ছে একটা ফ্যাক্টর। ফার্দার ফ্যাক্টর হচ্ছে অ্যাজ দ্য অবজেক্ট কিপস অন রোটেটিং, আমরা যে ভার্টিক্যাল হাইট ইউজ করে এফটাকে অ্যাপ্লাই করতেছি, হুইচ মিন্স দ্য টোটাল মোমেন্ট দ্যাট উই আর প্রডিউসিং বাই দ্য প্রোডাক্ট অফ এফ ইনটু এইচ, এই এইচটাও আস্তে আস্তে বাড়তেছে না? কারণ দিস পয়েন্ট ইজ স্লোলি গেটিং ভার্টিক্যালি অ্যাবাভ দেন দ্য ইনিশিয়াল পয়েন্ট।
জি স্যার।
তো আমাদের এইচটা যদি বেড়ে যায়, তার মানে আমাদের রিকোয়ার্ড এফটা কি হবে?
কমে যাবে স্যার।
এই তো। So both of these factors, একটা হচ্ছে the required anti-clockwise, the available anti-clockwise moment of the system gets reduced, that is one factor, and the height through which we are applying the horizontal force to produce the anti-clockwise moment, that is also becoming increased. Both of these factors add up to a মানে কি বলবো, to a combined effect that the required force will decrease. We have to support a smaller clockwise moment where the available height is more. বুঝছো? So ওই জন্য আমাদের ফোর্সটা আস্তে কমে যায়। So the reason I'm telling you this to give you the idea that we're going to need the maximum amount of force to start at the beginning. The further the rotation continues, the less F would be required. This is why the word minimum is mentioned over here. That to start this motion, we have to apply a certain amount of force over here. As the motion continues, the required force will slowly become less and less and less. But you'll have among all the forces that you have to apply to make the toppling motion happen from the application point over here all the way to the vertically above over here, among all of these points, you have to apply the biggest force exactly at the beginning. Other than applying any force any smaller than this, you cannot start the rotation. বুঝা গেছে? So for the motion case, this is the maximum force for the required motion all through from the point afterwards, but applying any force smaller than that, it does not work. That's why we are saying this is the minimum force, that this is the smallest force that we can apply, and any smaller the object will not start to rotate.
জি স্যার।
Okay, this is that. And then the next part that we have, Acha, this is actually the key part for the Lami's theorem, or how can we actually আচ্ছা আমি 3-4 সিনারিওস গুলো একে দেখালে জিনিসটা ইজিলি বোঝা যাবে। If an object is defined to be in equilibrium by the effect of 3 forces, let's say FA, FB, and FC, and let's say the angle that they produce with each other is given by alpha, beta, and gamma, then this equilibrium case can be represented by Lami's theorem, which is basically a very decent version of the sine rule for a triangle. Or I can write it in this way, that Lami's theorem works like this, that any of the force divided by the opposite angle of that force, so FA by sine alpha should be equals to FB by sine beta should be equals to FC by sine gamma. You should see that I conveniently chose this alpha beta gamma, which is opposite to this force. So FA force opposite side angle হচ্ছে alpha, FB opposite side angle this হচ্ছে beta, and FC opposite side angle this হচ্ছে gamma. So together they produce this equilibrium case. If you wonder how does this formula actually come into existence, this is pretty simple. We can come up with this formula or come up with this equation by the very basic sine rule of a triangle. How can we do that? If we go ahead and draw up these 3 forces in a triangle with appropriate scale and angle. In this case, I cannot actually go for the scale, so I'm gonna relying more on the angles. So let's say I'm gonna draw FA in this direction, and if B produces an angle beta with this one, so if I extend this line over here, and what is the angle between FA and FB? FA and FB has an angle of gamma between them. So FA আর FB এর মাঝখানে অ্যাঙ্গেল হচ্ছে গামা। সো এই পয়েন্ট থেকে আমি যদি এখানে গামা পরিমাণ অ্যাঙ্গেল ড্র করি, I should get the element of FB. Yes, so this is my FB. Let's say it goes up all the way up over here. This is the angle gamma. This is FA and this is FB. বলবান এই জিনিসটা বুঝছো কিনা দেখো, যে আমি গামা অ্যাঙ্গেলটাকে কোন জায়গাতে আঁকলাম। The angle between the FA and FB force, this angle is gamma. So the direction that FA is going by, FB is at anti-clockwise direction gamma angle further from the FA direction. So this is the angle of gamma that is picked up from this position to draw the new element of FB. So I'm trying to draw a triangle rule over here, placing the vectors one after another. Then FB is going this way. The angle between FB and FC is alpha. So if I extend this line, and from this angle I draw up another anti-clockwise angle that is equals to alpha, I should be able to draw the angle FC. So that is working this way. This is my FC, where this is the alpha angle. And obviously, if I extend this further down, the angle between FC and FA is obviously beta. So FC or FA masculine angle হচ্ছে beta. So this angle should be beta. So this is basically this same diagram drawn over here. And you should see over here that all of these angles that I have drawn on the outside of the triangle actually are the external angle, which essentially tells us that this internal angle should be 180 minus alpha, so 180 minus gamma. This should be 180 minus alpha, and this one should be 180 minus beta. Now you can very conveniently apply sine rule for this triangle. I'm going to apply sine rule for this triangle. So if I start with FA divided by this angle of sine, FA divided by sine of 180 minus alpha should be equals to FB divided by sine of 180 minus beta, which is right over here. This is the FB force. FB opposite side angle হচ্ছে eta, 180 minus beta, this one. Should be equals to FC divided by sine of 180 minus gamma. So that's the equation, and you should know from the trigonometry that this ratio ultimately becomes sine alpha, and this becomes sine beta, and this becomes sine gamma naturally, which means we have the Lami's theorem right over here. One of the key important part for you to understand that Lami's theorem is exclusively applicable. Lami's theorem is exclusively applicable for a 3-4 scenario. It is not applicable for a 4-4 scenario, not applicable for a 2-4 scenario. Finding out the resultant for a 2-4 scenario is pretty simple. I mean, if equilibrium has to be achieved by two forces, they have to be equal and opposite to each other, obviously. However, if you have more than two forces, that's where more significant other calculation needs to be involved. This can prove to be a much simpler way to equate forces in applicable scenarios, in required scenarios. However, if we have more than 3 forces in a certain given case, the whole consideration of component division, for example, let's say if I have an object, let me just show you another example. Let's say we have an object that is over here and we have 4 forces working on it. Just for the sake of simple discussion, let's say the force 1 is working this way, force 2 is working this way, force 3 is working this way, and maybe force 4 is working that way. So force 1, force 2, force 3, force 4. Let's say these are the angles that we have. Let's say the question is already giving out the individual angle between the forces. Let's say this is 60 degree. Let's say this is 90 degree, and maybe this is 225 degree. So let's say the question has given you these angles. So the remaining is remaining. 360 থেকে সাবট্রাক্ট করলে যা হয়। সো এই ধরনের অ্যাঙ্গেলগুলো যদি আমাদের দেওয়া থাকে, আমরা খুব ইজিলি জিনিসগুলোকে দিয়ে কম্পোনেন্টারি ইকুয়েশন করে ফেলতে পারবো। কম্পোনেন্টারি ইকুয়েশন কিভাবে করার সহজ বুদ্ধি হচ্ছে এরকম যে we can, if the question tells us that together all of these 4 forces produces a zero resultant on the object, or the object is still in equilibrium, we can go ahead and divide these forces into their horizontal components part by part. But you should see that F1 only has a horizontal component for this figure. It doesn't have any vertical component, so F1 cos 0 is the angle. So with the assumed positive x-axis, the angle that F1 produces is 0 degree. So I can write those equations like this. Have a look. I'm going to write the equations in a matching pattern so that you can understand what is happening. For the x-axis, this equation can look like F1 cos 0 plus F2 cos 60 plus F3 cos 150 plus F4 cos 225. Measuring all the individual angles from the positive x-axis. This much, then this whole much, then this whole much. By virtue, this should be 0. And for the y-axis, I can write the same equation where all the cosine should become sine. So I can write for that part, I can write F1 sine 0, which is basically 0, plus F2 sine 60 plus F3 sine 150 plus F4 sine 225 should be equal to 0. You might wonder one thing, that what if one of the forces is not perfectly horizontal? What do we do then? What if one of the forces is not given in the horizontal direction? Well, not a big deal. We can drop the horizontal force and eventually go for that calculation. So for example, if I copy this same exact figure and let's say F1 was not initially horizontal. Actually, before I go for that, এই equation build upটা কি বুঝা গেছে পোলাপান?
স্যার
হ্যাঁ বলো।
স্যার F3 এর জন্য আমরা 150 নিলাম, কেন আমরা ওই ইয়াটা নিতে পারতাম না 30 ডিগ্রি 180 minus 150 ডিগ্রি?
তোমাকে তাহলে সেটা হচ্ছে তোমার সেক্ষেত্রে তোমার প্লাস এন্ড মাইনাস আলাদা করে হিসাব করতে হতো, বিকজ 30 ডিগ্রি উড হ্যাভ বিন উইথ দ্য নেগেটিভ এক্স অ্যাক্সিস।
ইয়েস স্যার।
সো তাহলে তোমাকে নেগেটিভ এক্স থেকে যদি জাজ করতে, তাহলে তোমাকে বাই ডিফল্ট এখানে একটা মাইনাস সাইন বসায় 30 ডিগ্রি লিখতে হতো। আর যদি আমি cos 150 লিখি, বাই অটোমেটিক্যালি আমার cos 150 ভ্যালু আছে মাইনাস cos 30 চলে আসবে।
ওকে স্যার।
এভাবে লিখলে সুবিধাটা হচ্ছে যে আমি যদি সবগুলো অ্যাঙ্গেল পজিটিভ এক্সিস থেকে জাজ করি, আমার ইকুয়েশন লেখার সময় মাথা ঘামাইতে হচ্ছে না। সবগুলোতে আমি প্লাস সাইন দিয়ে জাস্ট পজিটিভ এক্স অ্যাক্সিস থেকে আমি সবগুলো অ্যাঙ্গেল অ্যান্টি ক্লকওয়াইজ অ্যাঙ্গেল লিখে দিলাম। আমি কিন্তু কোনটা ক্লকওয়াইজ অ্যাঙ্গেল লিখি নাই, খেয়াল করছো?
না স্যার।
সবগুলো অ্যান্টি ক্লকওয়াইজ অ্যাঙ্গেল, যেখানে সবগুলো অ্যাঙ্গেল ভ্যালু বসাইছে পজিটিভ, কোনটা কিন্তু নেগেটিভ বসায় নাই। This helps to write the equation in a much easier format because calculator will automatically define what is the value of this thing. So you can get rid of the mental pressure for your own self.
বুঝছি স্যার।
This is not the only way to write the equation. This is an easier way to write the equation. That's all I'm saying.
স্যার আমরা যে y কম্পোনেন্টের জন্য যে sin 0 নিচ্ছি স্যার এটা বুঝছি না sin 90 হওয়ার কথা না
F1
यस স্যার
sin 90 value 1, sin 0 value 0. F1 এর কি কোনো ভার্টিক্যাল কম্পোনেন্ট আছে?
নাই স্যার
F1
তাহলে নাই তো স্যার তাহলে f2 এর জন্য আমরা 30 নিলাম না এটা তো ভার্টিক্যাল কম্পোনেন্ট আছে
F2 এর ভার্টিক্যাল কম্পোনেন্ট আছে কিন্তু আমি এখানে অ্যাঙ্গেল ইউজ করছি 60 ডিগ্রি সো F2 যদি এদিকে হয় F2 এর ভার্টিক্যাল কম্পোনেন্ট লেটস সে আই এম গোনা ড্র দিস উইথ রেড লেটস সে সো F2 এর ভার্টিক্যাল কম্পোনেন্ট হবে এইদিকে আর হরিজন্টাল কম্পোনেন্ট হবে এইদিকে এই হরিজন্টাল কম্পোনেন্ট হবে কত F2 cos 60 আর ভার্টিক্যাল কম্পোনেন্ট হবে F2 sin 60
ও বুঝছি সরি यस স্যার বুঝছি
ক্লিয়ার হইছে
यस স্যার বুঝছি কনফিউজ
সমস্যা নাই ইটস ওকে সো দ্য আদার থিং দ্যাট আই ওয়াজ ট্রাইং টু সে দ্যাট this example that I brought about where one of the force was perfectly in the positive x-axis. What if this is not the case? মনে করো আমাদের কোশ্চেনের সিচুয়েশন দিচ্ছে এরকম যে এক কোন ফোর্সই আমাদের এক্সিস এর সাথে অ্যালাইন করা নাই সবগুলো ফোর্সেসেরই কিছু না কিছু অ্যাঙ্গেল আছে তখন কেমনে করব মনে করো আমি এই সেম ফিগারটা আমি এখন কপি করে নিব আমি এটাকে একটু ঘুরায় একটা ডিফারেন্ট একটা সিনারিওতে দেখাচ্ছি মনে করো এই হচ্ছে আচ্ছা মনে করো এটা হচ্ছে আমার সিনারিও I want to be able to rotate this. Can I rotate this? Okay, I can only take out this part and rotate this. So angle গুলো আমাকে আর লিখতে আছে অ্যাঙ্গেল গুলো লিখবো আমি সমস্যা নাই লাভটা কি হইলো
স্যার 225 অ্যাঙ্গেল কেমনে হলো f4 এর সাথে বুঝিনি এটা
ওহো আমি ভুল লিখছি সরি I wrote wrong thank you thanks for figuring that out I meant that from the positive x-axis all the way up till this point angle is 225 whereas a point থেকে oops whereas let me cut with red এই পয়েন্ট থেকে এই পর্যন্ত অ্যাঙ্গেল হবে হচ্ছে 225 minus 150 সাবট্রাক্ট করলে কত হয় 75 I meant that this much angle was supposed to be 75 degree only so that the total angle from this point all the way up to this point is 225 আমি ওটা মিন করতে গিয়ে 225 লিখছিলাম মাথায় হিসাব করে but this exclusive angle between f3 and f4 was supposed to be 75 degree I meant to write 75 degree my bad আর 225 টা হচ্ছে পজিটিভ x axis থেকে পুরো ক্লোজ অ্যাঙ্গেলটার ভ্যালু কত লাইক অল সাইন এন্ড কজ মেকানিজম আমরা যেরকম করি যে এখান থেকে সবগুলো অ্যাঙ্গেল হিসাব করতে থাকি ওই রকম জিনিসটা দেখাইছি বুঝছো
yes sir
sure thank you thanks for correcting me because it actually full angle does 225 but in between angle between f3 and f4 should supposed to be 75 I miswrote that আচ্ছা মনে করো আমাদের এরকম একটা সিনারিও দেওয়া আছে যেখানে কোনো ফোর্সই পারফেক্টলি ভার্টিক্যাল না বা পজিটিভ এক্সিস এর সাথে কোনো ফোর্স নাই so let me write these same numbers এখানে আমাদের 60 90 75 সো মনে করো এটা হচ্ছে 60 ডিগ্রি এটা হচ্ছে 90 ডিগ্রি মনে করো এটা হচ্ছে 75 ডিগ্রি এরকম মনে করো দেওয়া আছে ভ্যালুগুলো তো তখন আমরা কিভাবে কাজ করব ইটস প্রিটি সিম্পল what we simply have to do is just draw up a horizontal line through the center of gravity of the object or the working point of all the forces and measure up this force let's say this measure up this angle মনে করো তোমার এই অ্যাঙ্গেল মেজার করা এই অ্যাঙ্গেলটা যদি প্রোট্রাক্টর দিয়ে মেজার করবা ফিজিক্যালি মেজার করবা মনে করো সেই অ্যাঙ্গেলটা হচ্ছে থিটা আমি জানি না এটা কতটুকু ডিগ্রি অ্যাঙ্গেলে টিল্ট করা আছে আমি জানি না বাট মনে করো তোমার এই অ্যাঙ্গেলটা আসলে থিটা এখন তুমি এই থিটা অ্যাঙ্গেল ইউজ করে বাকি পুরো ইকুয়েশন আবার ডেভেলপ করতে পারবা কিভাবে ডেভেলপ করবা for example in this case that is going to look somewhat like this let me write this on the x-axis, this is gonna look like f1 cos x cos theta plus f2 cos 60 plus theta plus f3 cos 150 plus theta plus f4 cos 225 plus theta equals to 0. On the y-axis, this is gonna look like that's how we approach the problem. And question হচ্ছে যে এই থিটা ভ্যালু কি কোশ্চেনে দেওয়া থাকবে? ওয়েল, কোশ্চেনে দেওয়া থাকলে তো আমাদের ক্যালকুলেশন অনেক ইজি হয়েই গেল। আর যদি থিটা ভ্যালু কোশ্চেনে দেওয়া না থাকে, তো আমাদেরকে সিম্পলি ফিজিক্যালি ড্র করে পজিটিভ এক্সিস এর সাথে অ্যাঙ্গেল কত সেটা বাই করতে হবে। ইন দ্যাট কেস অল অফ দোজ থিটা নাম্বারস, থিটা symbols that I have written in this equations, they would simply become numerical value, so making the equation much too simpler to work with. বুঝছো কি বলছি বলবান? Bottom line that I'm trying to show you in this whole discussion in both of these figures is that if you make up your component division forces, all of them judging from the positive x-axis, যদি আমরা এটা করি তাহলে আমাদের ইকুয়েশন লেখার সময় কোনো রকম মাথা ঘামানো লাগবে না। পজিটিভ এক্স-অ্যাক্সিস থেকে যদি আমরা অ্যান্টি ক্লকওয়াইজ অ্যাঙ্গেল লিখে করি তাহলে আমাদের পুরো ইকুয়েশনগুলো খুব ইজিলি বিল্ড আপ করা পসিবল। You just have to write the angles and the equation is going to work out on its own. Make sense so far?
থিটা দেওয়া না থাকলে কি করব?
এটা যদি দেওয়া না থাকে তাহলে সেক্ষেত্রে তোমার নাম্বার অফ ইনভলভ ফোর্সেস গুলো সবগুলো ভ্যালু দেওয়া থাকতে পারে। তোমাকে কোশ্চেন বলতে পারে যে তুমি থিটার ভ্যালু বাই করো, মনে করো তোমাকে f1 f2 ভ্যালু দিয়ে দিছে, অথবা এরকম হতে পারে যে তোমাকে হয়তো লেটস সে তিনটা ফোর্স দিয়ে দিল, লেটস সে মনে করো তোমাকে, আচ্ছা মনে করো চারটা ফোর্সের মধ্যে f1 f2 f3 দিয়ে দেওয়া আছে, f4 এর ভ্যালু দেওয়া নাই আর থিটা ভ্যালু দেওয়া নাই, তাহলে তোমার আননোন হলো কয়টা?
দুইটা।
ইকুয়েশন কয়টা?
বুঝছি স্যার।
বুঝা গেছে? সো ইকুয়েশন ভেবে দিবে যদি তোমার মানে if you have to solve the equation maximum যদি দুইটা আননোন থাকে তাহলে দুইটা ইকুয়েশন বিল্ড আপ করা যাবে। যদি তোমার মানে দ্যাটস হাউ দ্য ম্যাথ ইউজুয়ালি ওয়ার্কস। হয়তো এরকম হতে পারে যে তারা থিটা দিয়ে দিছে, চারটা ফোর্সের মধ্যে দুইটা ফোর্স দিছে আর দুইটা ফোর্স দেয় নাই, সো তখন আমাদের ওই দুইটা ফোর্স দিয়ে আমাদের বাকি ম্যাথটুকু করা লাগবে। বুঝা গেছে?
ইয়েস স্যার।
আচ্ছা, yes, we have a question in the chat. Amin sir, okay, আচ্ছা, ওয়ালাইকুম আসসালাম। আচ্ছা আমিনুল স্যার আমি যোগাযোগ করব, ঠিক আছে। হাসান, থ্যাংক ইউ।
ওয়েলকাম স্যার।
তারপর হচ্ছে আর কিছু নাই। That's pretty much it for the forces and moment theory discussion. আমাদের অ্যাডিশনাল আরো কিছু পার্ট আছে যেটা অ্যাকচুয়ালি আমাদের এই লেকচারে ঢুকানো হয় নাই, আই ডোন্ট নো হোয়াই। ওই পার্টটা আমি তোমাদেরকে পড়াবো, দাঁড়াও, এটা মনে হয় আমাদের নোটে তো থাকার কথা, নোট নাই কেন? নোটে এর থেকে আর বেশি কিছু নাই? হাই হাই, the equilibrium cases for the ladder cases গুলো এখানে ইনক্লুড করা হয় নাই। হাই হাই, ladder cases কই? প্রবলেম। আর দিন the working GPR notes. না, আচ্ছা আমি তোমাদেরকে ল্যাডার কেসেসটা নরমালি পড়াই, এই পার্টটুকু তোমাদের একটু লিখে নিতে হবে কারণ এটা সামহাউ তোমাদের নোটসে নাই। I think I forgot to copy this, or maybe somehow this part of the discussion is not within your notes. So everyone please pull up your copies. I'll ask you, I mean, I'll tell you when to write something, but before I ask you to, I need to see first and then I'll ask you to copy these figures. আমি এই পার্টটা গুছাই লিখবো যাতে করে তোমার কপি করতে সমস্যা না হয়। খেয়াল করো, one of the key part that we need to understand is that friction is pretty much a default force in most of the contact case scenarios. how friction will affect our motion is to be judged based upon the direction of motion of the object or the possible direction of the motion of the object. Possible direction বলতে আমি জিনিসটা বোঝাচ্ছি এরকম যে let's say if we have an object right over here sitting on a certain surface and there is a friction between the object and the surface. If we apply a small force on this object in this direction and the object doesn't move, it simply means that the friction in this case is working to the left. So even if the object is not moving, because our applied force is perfectly being counterbalanced, so the friction is moving working to the left. If you start to apply bigger force, the bigger friction is going to be available. At one point, if our applied force becomes bigger, then the possible biggest value of the friction for the contact between the object and the surface, then our object will have a resultant force, and that resultant force can start accelerating the object to the right. For this example, so object move na korleo friction hoy. Static case of friction available hote pare if object has a tendency to move. So this is basically what is going to be required for our next part of this discussion. Let's say we have I'm going to draw 4 different scenarios over here. Let's consider the vertical lines are a wall and the horizontal line is a ground. And on this thing, we have a ladder. A ladder is resting on the wall and the ground like this. And we want to figure out whether the ladder will move or not, or in other words, whether the ladder should be in equilibrium or not, based upon the presence of friction on these two surfaces. Now, first thing first, if we place the ladder in any of the cases or in all of the cases, I can draw them in all the individual figures. Let's say the ladder is like that. The angle really doesn't matter for the time being, so disregard different alignment or different length of the ladder. Disregard that. One default force we'll definitely have is the weight, which is undeniable. So what will be working vertically downwards from the center of the ladder for all the cases. Now, this weight force will naturally try to pull the ladder down. If the ladder is to move downwards, you should to understand that this contact point should move to the right and this contact point should move downwards. এই জিনিসটা বোঝা যাচ্ছে কিনা? The ladder যদি পড়ে যেতে থাকে while resting on the wall and ground like this, the ground contact point should move further away from the wall and the wall contact point should move closer to the ground. এটা হওয়ার কথা কিনা? বলবান?
Yes, sir.
এখন যদি আমাদের ফ্রিকশন সিস্টেমে থাকে, সিস্টেমে যদি ফ্রিকশন থাকে, আচ্ছা ফ্রিকশনের পার্টটা একটু পরে বলতেছি, ওয়েটের জন্য and because the ladder is resting over here, we will also have some default reaction forces over here, which I'm showing by red arrows, because reaction forces are always present provided you have contact forces. So we should have reaction forces by default. সবগুলো কেসে রিঅ্যাকশন ফোর্স আমি আঁকতে ভুলে গেছিলাম, ওইটার পরে রিঅ্যাকশন ফোর্সটা আঁকার কথা ছিল, or I forgot. So all the forces have reaction forces. But next, coming to the point of friction. Now, if we have friction, whether we are going to consider the friction or not, that's a simple scenario. For example, in this case, we are considering both the wall and floor rough. If that's the case, that would mean at this point we're going to have a little bit of force for the friction in the upward direction. This point is going to have a little bit of force in the left direction. This is bound to happen. This will ultimately lead that the resultant force of these two forces should be somewhere in the upper right direction, in the upper right quadrant. So if I draw that force, let's say somewhat with this color, maybe in this direction, and I'm extending this line a little bit so that I can find out the possible cross point of W and that force. Let's say this point is right over here. So the resultant force working on the top of the ladder and the resultant force working and through the weight is meeting over here. Now, what you need to judge, is it possible that the resultant of these two forces might go through there? Is it possible? I mean, should it or not, that's a different issue. But is it possible that the resultant force might go through there? You can see that the two individual forces, reaction forces working vertically upwards, the friction forces working to the left. So the resultant of these two forces can actually exist in the upper left direction or in the second quadrant, upper left direction. So এখানে যদি আমি এই পয়েন্টটাকে অরিজিন ধরি তাহলে আমার resultant ফোর্সটা অ্যাকচুয়ালি এই ডিরেকশনে কাজ করা পসিবল such that this force is perfectly aimed towards that dot. এটা possible. This actually goes on to show us that it is possible for this scenario when both the wall and the floor both are rough, that the three individual forces, the combined force, resultant force from this top point, the resultant force from the bottom point, and also the weight, all of these three forces can logically have one single common point. So equilibrium is possible. So it is possible that if both the surfaces are rough, the ladder can be stationary. Whether it will be stationary or not, এটা পরের জিনিস, এটা আমরা একটু পরে দেখতেছি. Equilibrium is possible. If I go for the same scenario over here, but with a little bit of difference. Acha, let me just try go over here by showing the case where both the things are smooth. Let's say for the fourth figure, I'm going to show you both wall and floor smooth. If this is the case, then what's going to happen? This would mean that we don't have any presence of friction, which means these green arrows would be altogether missing from the figure. These reaction forces are the only forces available at the contact points. So now what we want to judge is it possible for these three forces to have a common crossing point? Now what you'll find out, if I just extend out this force and extend out each of these two forces, because they are perfectly parallel to each other, we cannot have a common cross point. This reaction force and this reaction force are working in this point, whereas this force is working over here. So, and these two forces will not have a common cross point whatsoever because they are simply parallel to each other. So it means that these three forces, whenever both the surfaces are smooth, we cannot have a common cross point, which means resultant moment cannot be zero. This basically goes on to show that for a scenario like this, equilibrium not possible. এই দুটো এক্সাম্পল বুঝছো কিনা? Anyone question?
স্যার প্রথম পার্টটাতে স্যার ওই আপওয়ার্ড ফোর্সটা কেন হবে স্যার? ওটা
Because-
বুঝি নাই স্যার।
Because we consider the wall is rough, so naturally the ladder is about to slide downwards. So if the ladder is trying to slide downwards, the friction of this contact point should be working upwards. I mean, মনে করো
স্যার রেজাল্টেন্ট একটা ফ্রিকশন ফোর্স তৈরি করতেছে বাই ট্রায়াঙ্গেল রুল which is acting opposite to the motion of the ladder against the wall.
no, resultant is not producing the frictional force. The reaction force, which is red, and the friction force, which is green, together producing the resultant force, which is the rainbow color.
জি স্যার বুঝছি স্যার।
Acha. So for this in between two figures, we're going to cover or consider one of the surfaces to be rough. For example, let's say let's consider over here, let's say wall rough and floor smooth. So what happens for this case? If wall is rough, then we're going to have the friction force of the wall over here. So this force is going to be right over there. And if floor is smooth, floor is not going to have any friction force, which means in this case, we're going to have the resultant force in the upward direction. So let's say the resultant force could be any of the upward right direction, doesn't matter. But these two forces will not, this one, the ground friction would not be there. Now, once again, if I extend this working line, right, like that, and extend this working line and extend this working line as well, what you should find out that also in this case, these two forces cannot have a common cross point because they are perfectly parallel to each other. And also if you consider the common cross point of this resultant force from the top end with the weight or with the reaction force from the ground over here, we don't simply have a common cross point of all the three forces. If that is the case, we are going to say equilibrium not possible.
স্যার
Yes.
স্যার যেহেতু ফ্লোরটা স্মুথ তাহলে এটা কি ফোর্স দিচ্ছে?
Only the reaction force. যতটুকু ওয়েট ওই পয়েন্টে কাজ করতেছে, ওয়েটের ইকুয়াল ফোর্সে আপওয়ার্ড ব্যাক অ্যাপ্লাই করতেছে।
বুঝছি।
Okay. So obviously this case over here should be wall smooth and floor rough. What's going to happen for this case? The the friction force for the wall would be absent, whereas the friction force for the floor would be there. So let me just try and draw that. And now the resultant force for the bottom corner can be working in the upward left direction. So now if we try to find out the possible cross point of all the forces, let's say I extend this one a bit to the horizontal, I extend this one a bit to the upward direction, but I can find out that it is possible that the resultant force of this point might actually work through this point. I'm not saying it will happen, I'm saying it is possible. Okay. So in this case also we can have equilibrium possible. So combinedly যদি আমরা সবগুলো ফিগার দেখি, the bottom line is that equilibrium থাকতে হলে অবশ্যই গ্রাউন্ড কে রাফ হইতে হবে। ওয়াল যদি রাফ হয় অথবা ওয়াল যদি রাফ নাও হয় তাও equilibrium possible. So for these two left cases we had the ground rough and we had equilibrium possible. For these two right cases, floor was smooth and there was no equilibrium. If our wall has some roughness, or if wall has friction, then the then the resultant force is going to work at a bit angle. So এই হচ্ছে চারটা ইন্ডিভিজুয়াল ফিগার যেটার উপর বেস করে আমরা ইন্ডিভিজুয়াল ডিফারেন্ট ডিসিশন নিতে পারি। This is the part that you are supposed to copy additional to the class note. তোমরা একটা সিম্পল পিস অফ পেপারে যদি এঁকে নাও, পরে সেটা তোমার ক্লাস নোটের সাথে টেপ দিয়ে বা গ্লু দিয়ে আটকায় নিলে বা স্ট্যাপলার করে নিলে, তাহলে তোমাদের জিনিসটা হারাবে না। আর খাতা যদি লেখো তাহলে পরে আবার খাতা কোথায় আছে খুঁজে পাইতে সমস্যা হতে পারে। So I recommend that you try to copy this in a piece of paper, in a single piece of paper. But before I allow you to copy this thing, I'd like to show you one MCQ that is relevant for this question, which is right over here. Question number 16, the latter case. Select হয় না কেন? কি সমস্যা? Let's have a look at this MCQ. Which one do you think is the correct response? পড়ো, কোশ্চেনটা পড়ো।
B হবে।
B is the correct response. Now, do you understand why?
যেহেতু গ্রাউন্ড ফ্রিকশনলেস তাই ওখানে জাস্ট আপওয়ার্ড ফোর্স অ্যাক্ট করবে, আর
Okay.
ওয়াল রাফ তাই ওখানে রেজাল্টেন্ট হবে একটা।
B is the correct response for this question because the wall is considered to be rough, while the ground is considered to be frictionless. So গ্রাউন্ডের রিঅ্যাকশন ফোর্স শুধু ভার্টিক্যাল হবে আর ওয়ালের ফ্রিকশন টোটাল ফোর্সটা প্রোডিউস সাম অ্যাঙ্গেল হবে। এটা হচ্ছে একটা বেসিক জিনিস। আচ্ছা, আরেকটা কনসেপ্ট আলাপ করি। আচ্ছা, বিফোর আই গো ফর অ্যানাদার কনসেপ্ট, আই উড লাইক আইড গিভ ইউ সাম টাইম টু কপি দিস হোল পিকচার। লেখাগুলো কি পড়া যাচ্ছে বলবান? এই চারটা ফিগার এবং এই লেখাগুলো একটু লিখে নাও। I'll give you 5 minutes. 5 minutes না, I'll give you 3 minutes. So the next part that I would like to discuss is also actually another very common basic concept. সেটা হচ্ছে the idea of center of gravity or center of mass of an object is such that if we consider the total mass of an object concentrated at a single point, if we consider the total mass of an object concentrated to be in a single point, which is considered the particle representation of that object, the weight of an object works through that point. তার মানে হচ্ছে মনে করো এটা একটা অবজেক্ট, জাস্ট একটা রেক্টাঙ্গুলার পিস অফ অবজেক্ট, ইটস এ ইউনিফর্ম অবজেক্ট। এটার ওয়েট কারেন্টলি এই জায়গা থেকে আসছে। অবজেক্টটা কিভাবে সাপোর্ট করা আছে সেটা আমি বলতেছি না। আচ্ছা, অথবা আমি সাপোর্ট করা পজিশন দেব, মনে করো হচ্ছে এখানে একটা সাপোর্টিং সাপোর্টিং পয়েন্ট আছে, এখানে একটা সাপোর্টিং পয়েন্ট আছে। একটা প্ল্যাঙ্ককে আমরা রেক্টাঙ্গুলার প্ল্যাঙ্ককে আমরা এভাবে বসায় রাখছি। So what is working through the center, and in this point, in this case, the reaction forces of these 2 points would be will be exactly equal because the distances are exactly equal. Now, if I displace the position of the center of gravity of this whole object, for example, let's say now I'm gonna add one significant mass right over here. মনে করো এখানে বড় একটা mass এখানে বসাইলাম, তাহলে কি হবে? এই অবজেক্ট এখন আর, I mean, consider the total object as the sum of the plank and the blue object. Now this whole thing is not going to be as a uniform object because now there is more mass on the right side compared to the left side, which means the center of gravity would be significantly shifting to the right. Should it be exactly under this one? No. Should it be exactly at this point? No. The new center of gravity for the combined object should be somewhere in between. The positioning of this object is going to shift the center of gravity slightly to the right. So let's say this would be our new weight of the whole system, combining the weight of this one and this one together. So এই আমাদের center of gravity টা যেখানে massটা বসাইছি সেদিকে হালকা একটু সরে আসবে, and the total value of the whole weight of the system is going to get bigger. This is going to cause this reaction force on this two support will also change. This reaction force is going to rise up by a high amount. This reaction force is also going to rise up, but by a small amount. This is not going to become smaller. The reason this is not going to become smaller because the total weight of the system is definitely bigger than the earlier. পুরো সিস্টেমের টোটাল ফোর্স কিন্তু ওয়েট আগের থেকে বেড়ে গেছে। তার মানে হচ্ছে কি ইন্ডিভিজুয়াল রিয়েকশন ফোর্স গুলো বাড়তে হবে। Just because the center of gravity moved to the right doesn't mean that this force is going to remain same or this force is going to remain constant. So that's how the position of center of gravity of an object changes as we add more and more mass on one object. এটা হচ্ছে একটা কনসিডারেশন। আরেকটা কনসিডারেশন হচ্ছে if we move the object more to the right, let's say আমি যদি এই ব্লু অবজেক্টটাকে, can I select this whole blue object as a one? I can. If we move the whole blue object bit more to the right, let's say if I place the blue object right over here, then what should have happened? In that scenario, this whole thing would move more to the right along with this. Shift দিয়ে মাল্টিপল সিলেক্ট করা যায় না? যায় না। কন্ট্রোল দিয়ে করা যায় না? যায় না। ভালো। Can I use loop while overlapping objects? I can. Beautiful. In this case, the entire center of gravity would be moving more to the right, and that is going to cause a significant increase in the reaction force on this side, and this reaction force is going to drop a little bit than earlier, but still going to be bigger than the exclusive weight of the single plank. The point that I'm trying to show you is that the position of mass on an object where we can have a changing position of mass the center of gravity of the object can significantly change. But this plank would be stable as long as this combined center of mass working weight point is still in between these two support points. A support point দুটার মাঝখানে যতক্ষণ পর্যন্ত এটা থাকবে ততক্ষণ পর্যন্ত এই অবজেক্ট স্টেবল থাকবে. If I move the stone too much far out on the right side so that this center of gravity falls outside the support point, then the whole system is going to topple over. The entire system is going to topple over. এটা এই জন্য বলতেছি, this is basically how cranes topple over. For example, the question right above this one, question number 15, if you have a look at this question, have a look at this one. Zoom out a little bit and maybe minimize the ribbon. Okay, take a look at this question number 15. Have a look. The question says the diagram shows the crane supporting a load L. A mass provides the balancing load W. The position of the load is such that the system is perfectly balanced with Wx equals to Ly. The ground provides a reaction force R. The distance x does not change. If the load is moved further out so that the distance y increases and the crane does not topple, important part, the crane does not topple, which statement is correct? So we are going to move the L further out, which means y will increase. If y is moved further out, in that case, the object is gonna start to have a center of gravity changed. So that's gonna cause the object to move slowly further out to the right. And before I give you any hints, which one do you think is the correct answer? Bolo.
Sir, what do you mean by object? Do you mean that the plank and the plank or the square that represents directions from L?
Oh, in this case, the object in this case, I'm trying to mean is that by saying object, I'm meaning the load. The L is moved further out. Further out means that the y is increased. So the combined center of gravity of the object should move in which direction?
To the right.
But still through the base of the crane, because the question says that the crane does not topple over, which means the crane is still supported by the
right
supporting system. So এটার correct response টা কি হবে?
D.
Correct response হবে D. And the reason it has to be D because the question says the crane does not topple over. Now here is a catch. If the crane was to topple over, if the crane was to topple over, then what would have happened? If the crane was to topple over, then this reaction force should be outside the base. That is basically how many cranes actually fall over. I mean, if the আমাদের অনেক ফেল ভিডিও দেখি না আমরা, যেখানে দেখা যায় যে ক্রেন উল্টায় পড়তেছে এন্ড পাল্টায় পড়তেছে. The idea is that they have their base within a certain space and they are trying to lift out such a big mass that the total reaction force working point fell out of the total chain base of the crane, and that's why the crane toppled over. That is one of the scenarios. Or the crane lifted a single weight while it was stable, but it is trying to drop the weight at a such far away distance from its own position that the center of gravity of the total system is falling outside the base of the crane, and that's when the crane flips over. So this is a pretty interesting video in the YouTube channel Practical Engineering by Cody. I would like all of you to see this video. I'm just going to show you how to find that, and then we'll call it a day because some students have class at 9:30. So I'm going to try to finish right now. If you just find why cranes fail, the first video you're gonna get is from Practical Engineering. So this is the video. I recommend that you all see it. It's a pretty new video.
Sir, can you give the link?
No, the reason I don't want to give the game is the same reason that I'm showing you how to find this.
Okay, sir.
Sure, no problem. All the best. Assalamu alaikum.
Assalamualaikum, sir.